Today we are going to discuss about trigonometric identities. Basically, we have three identities. What is the first identity? The first identity is sin square theta plus cos square theta is equal to 1. This is the first identity. From this first identity, we will get two sub-identities. Sin square theta is equal to 1 minus cos square theta. By transposing cos square, we get this formula. If you transpose sine square, you will get one more formula, that is cos square theta is equal to 1 minus sine square theta. These two are sub-identities. This is main identity. Okay. Second identity is secant square theta minus tan square theta is equal to 1. Secant square theta is equal to, on transposing tan square, what would you get? 1 plus tan square theta. At the same time, if you transpose 1 inside and tan square outside, you will get one form sub-identity. Tan square theta is equal to secant square theta minus 1. So these two are sub-identities. This is the main second identity. Secant square theta minus tan square theta is equal to 1. From the main identity, we'll get sub-identities by just transposing. Let us see what is third identity. Third identity is cosecant square theta minus cot square theta is equal to 1. By transposing cot square, you will get one sub-identity, that is cosecant square theta is equal to 1 plus cot square theta. By transposing 1 inside, by transposing 1 inside and cot outside, you will get, just by transposing this 1 inside, you will get cot square theta is equal to cosecant square theta minus 1. So these are the three identities which you have to learn in this fourth exercise. So to do the problems of exercise 4, you need to learn all these identities. Apart from these identities, you should learn reciprocals. Sin theta is equal to 1 by cosec theta. Cosec theta is equal to 1 by sin theta. That means reciprocal of sin is cosec, reciprocal of cosec is sin. Cos theta, reciprocal of secant is cos. Secant theta, reciprocal of cos. Reciprocal of cos is secant. Tan theta is reciprocal of cot. Cot theta is reciprocal of tan. So you should know about these reciprocals if you want to deal with the fourth exercise. That is trigonometric identities. Apart from this, tan theta can be written as sin theta by cos theta. Cot theta can be written as cos theta by sin theta. So these two last formulas are called tan in terms of sin cos, cot in terms of cos sin. So if you are thorough with this identities, reciprocals and tan cot formula, You can do almost every problem of exercise 4. Okay. Apart from this, you should also know some algebraic identities like a plus b whole square is equal to a square
plus B square.
2ab plus b square, a minus b whole square is equal to a square minus 2ab plus b square. A cube plus b cube is equal to a plus b whole cube minus 3ab into a plus b. This formula, sometimes we use this formula. A cube plus b cube is equal to a plus b whole cube minus 3ab into a plus b. And moreover, a plus b into a minus b is equal to a square minus b square. At many places we use this particular formula. So what all we need to learn to do the fourth exercise without any problem? First, we have to learn the identities and sub-identities, then reciprocals, and this tan in terms of sine cos, cot in terms of sine cos, then these algebraic identities. Okay. I will explain how we got this a cube plus b cube formula. First of all, you know a plus b whole cube formula. Can anyone tell a plus b whole cube formula? A cube plus b cube
plus 3a square
minus 3 plus 3a square b plus 3ab
plus 3a.
square is the formula. A plus b whole cube can also be written as a cube plus b cube. On taking 3ab common, what will remain? From these two terms, if I take 3ab common, a plus b will remain. A plus b will remain. By transposing this part to other side, we will get our required formula. This plus will become minus 3ab into a plus b is equal to a cube plus b cube. That's it. Now I'm going to give proofs of identities. So let us prove the first identity. First identity is sine square theta plus cos square theta is equal to what? 1. Okay. Take a right angle triangle. ABC are the vertices. Angle B is 90 degrees. This is theta. So adjacent, opposite, hypotenuse. Tell me the ratio of sine theta.
Opposite.
Sine square theta. Cos theta ratio. I am taking left hand side. Adjacent by. So separate the squares. Opposite square by hypotenuse square. Adjacent square by hypotenuse square. What is the LCM?
Hypotenuse.
So opposite square plus adjacent square. Can anyone tell what is adjacent square plus opposite square according to Pythagoras theorem? Adjacent square, hypotenuse square by hypotenuse square is equal to 1. LHS is equal to RHS. Sine square theta plus cos square theta is always 1. No matter what angle theta is. Got it? Take theta as 30 degrees. Sine square theta, sine square 30, cos square theta, cos square 30. Sine square 30 is, sine 30 is 1 by 2. Cos 30 is root 3 by 2, 1 by 4, 3 by 4, LCM 4, 1 plus 3, 4 by 4 is equal to 1. No matter what theta is, you will always get 1. Take theta is equal to 60 degrees now. Take theta is equal to 60 degrees. Put in the identity. Identity says that sine square plus cos square is equal to 1. Theta is 60 degrees. Sine square 60. Cos square 60. I am taking LHS. I should get RHS. That is 1. What is sine 60?
Root 0.
Root 3 by 2 whole square. Cos 60. So 3 by 4 plus 1 by 4. 3 plus 1 by 4 is equal to 4 by 4 is equal to 1. Take any angle, you will always get 1. That's why this identity is true. Let's take theta is equal to 45. Sine square theta plus cos square theta should be equal to 1. So theta is equal to 45. Substitute sine square 45 plus cos square 45. 1 by root 2 whole square. 1 by root 2 whole square is equal to 1 by 2. Square and root will cancel. Half plus half is what? Again 1. Even if it theta is 45, you are getting 1. Got it?
Yes.
Take theta is equal to 0. Sine square theta plus cos square theta is always equal to 1. Let us see. Sine square 0 plus cos square 0. LHS I am taking. Sine 0 is 0. Cos 0 is 1. 0 plus 1 is equal to 1. Hence proved. Okay. Even if you take theta is equal to 90, definitely you will get 1. So sine square theta plus cos square theta is equal to 1. So whenever you see sine square theta plus cos square theta, you should write it as 1. Sine square a plus cos square a will also be equal to 1. Sine square alpha cos square alpha is equal to 1. Got it?
Yes, sir.
Proof of second identity. Second identity is secant square theta minus tan square theta is equal to 1. Let us prove this. Let us take a right angle triangle whose vertices are ABC, right angled at B, theta adjacent side, opposite side, hypotenuse. Can you tell the ratio of secant? I am taking left hand side. What is left hand side? Secant square theta minus tan square theta. I should get right hand side. So first of all, can you tell what is the ratio of secant? Hypotenuse by adjacent, isn't it?
Yes.
Tan theta is
Opposite by.
give square to both numerator and denominator. Hypotenuse square by adjacent square minus opposite square by adjacent square. What is the LCM?
Adjacent.
Adjacent square is the LCM. What will remain in the numerator? Hypotenuse square minus opposite square. What is Pythagoras theorem? Hypotenuse square is equal to adjacent square plus opposite square. On transposing opposite to other side, what would you get?
Hypotenuse square minus opposite square is equal to adjacent square.
So hypotenuse square minus opposite square is nothing but
Adjacent square.
Adjacent square by adjacent square is equal to 1. This proof is called geometric proof. This proof is called geometrical proof of identity. And here in the brackets, I'm going to write, since hypotenuse square minus opposite square is equal to adjacent square. So I have replaced hypotenuse square minus opposite square as adjacent square. So let us take some angle and prove it. Theta is equal to 30 degrees. Identity is secant square theta minus tan square theta is equal to 1. Let us take LHS, secant square 30 minus tan square 30. What is secant 30? Secant 30 is 2 by root 3. Tan 30 is 1 by root 3. Please square it. 4 by 3 minus 1 by 3. What is the LCM?
3.
3 by 3, which is nothing but 1. We got our RHS. We have taken LHS and got RHS. Similarly, you take any angle, you will get 1 only. For example, I am taking theta is equal to 45 degrees. Secant square 45 minus tan square 45. Let us check whether it is 1 or not. Secant 45 is root 2. Tan 45 is 1.
1.
Square root cancel. 2 minus 1 is equal to 1. So secant square theta minus tan square theta is always equal to 1. Proof of third identity. The third identity is cosecant square theta minus cot square theta is equal to 1. Let us take a right angle triangle whose vertices are ABC. Right angle is at B, theta is at A, so adjacent, opposite, hypotenuse. Let us take left hand side. Cosecant square theta minus cot square theta is the left hand side. Cosecant is the ratio of hypotenuse by opposite. Cot is the ratio of adjacent by opposite. On squaring, we will get hypotenuse square by opposite square minus adjacent square by opposite square. What is LCM? Hypotenuse square minus adjacent square. According to Pythagoras theorem, we know that hypotenuse square is equal to adjacent square plus opposite square. On transposing adjacent to the left hand side, we get hypotenuse square minus adjacent square is equal to opposite square. So this part, this numerator, hypotenuse square minus adjacent square, will become opposite square. By opposite square, both will get cancelled. Answer is 1. LHS is equal to RHS. This is the geometrical proof of third identity. We can even prove with taking an angle theta is equal to some 60 degrees. Let us take the identity cosecant square theta minus cot square theta is equal to 1. Cosecant theta is 60. Let us take LHS. Cosecant square 60 minus cot square 60. What is cosecant 60? Cosecant 60 is
2 by root 3.
2 by root 3 whole square. Cot 60 is 1 by root 3 whole square. So 4 by 3 minus 1 by 3, which is nothing but 4 minus 1 by 3, which is 3 by 3, which is equal to 1. We got our RHS. So no matter what theta is, cosecant square theta minus cot square theta is always equal to 1. So third proof is also given.